In our previous session, we discussed about force. What is force? Force is a push or pull up an object. It causes motion or it opposes motion. Okay. In today's class, we discussed about Aristotle's law of motion. So, this Aristotle's law of motion states that a continuous external force is required to keep a body in continuous motion. Aristotle's law of motion states that continuous external force is required to keep a body in, is required or is needed to keep a body in continuous motion. To keep a body in continuous motion. Aristotle's law of motion states that a continuous external force is required to keep a body in continuous motion. That means, according to him, suppose a force is applied to an object, the object starts moving. Suppose if I apply force to this object, what happens? The object starts, that means the duster starts moving. If I remove the force, the object comes to rest. If I want to keep the body in the duster in continuous motion, then I apply force continuously. That means a continuous external force is required to keep a body in continuous motion. So continuous move ಆಗ್ತಾನೆ ಇರಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? Continuous force apply ಮಾಡ್ತಾನೆ ಇರಬೇಕು. ಆಯ್ತಾ? So continuous force apply ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಒಂದ್ಸಲ force apply ಮಾಡಿದ ತಕ್ಷಣ ಅದು ಮೂವ್ ಆಗಲ್ಲ. ಏನಾಗುತ್ತೆ? ಮೂವ್ ಆಗಿ ಸ್ಟಾಪ್ ಆಗೋದು. ಸೊ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಿರಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡ್ತಿರಬೇಕು? ನಾವು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ನ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಅಪ್ಲೈ ಮಾಡ್ತಾನೆ ಇರಬೇಕು. That is the Aristotle law of motion. Continuous external force is required to keep a body in continuous motion. Okay, but this law is fails because the continuous external force is not required to keep a body in continuous motion. It is required to overcome the frictional force. So this fact was not known to Aristotle. So it is known as Aristotle's fallacy. Instead of Aristotle's law, now we call this as Aristotle's fallacy. Okay, because according to him, a continuous external force is required to keep a body in continuous motion. So this was corrected by Galileo. Okay. So suppose let us consider an object placed on a table like this. Okay. This is table and this one is the object. This object is placed on a table. Okay. When the object is placed on some surface, there is a contact force. That contact force exerts the frictional force. That frictional force is represented by small f. Frictional force is nothing but pseudo force or false force, or it is also known as invisible because it is invisible. Okay, this frictional force just acts only when the two surfaces are which are in contact. The frictional force acts only when two surfaces are in contact, and this frictional force is always acts opposite to the direction in which the force takes place. Here, when the object is kept on some surface, there is a contact between the object and surface. So it exists frictional force. If we want to move this object, so we apply the force against to the frictional force. That is capital F. Capital F is the, don't confuse the small f and capital F. Capital F is the applied force, small f is the frictional force. If we want to move the object, then we apply the external force in the direction of opposite direction. That means frictional force is always acting opposite to the applied force. Okay, as we apply the applied force, the frictional applied force overcomes the frictional force. That is F is greater than F. The body starts moving. If I remove the external force, again F is less than less than, yeah, that means by remove the external force means external force is equal to 0. That means frictional force is greater than the external force. Then the body is at rest. If I apply the force, then if applied force is greater than frictional force, then the body starts moving. If I remove the external force, the applied force is less than this frictional force is greater than the applied force. Okay, then the body starts moving. That means here the external force is required to keep extra force is required to overcome the frictional force or resistive force. There is no frictional force is known as resistive force. Resistance means opposition. This opposite force opposes the motion of an object. To overcome that opposition, we apply the applied force. So here the external force is not required to keep a body in continuous motion. It is required only to overcome the frictional force. For example, if you consider a ball is rolling on the frictionless surface. Notice, ball is rolling on the frictionless surface. Frictionless surface means friction is less or friction. There is no friction. If there is no friction, suppose the ball is rolling on the smooth surface, the ball starts moving until someone push or someone pull it. Okay. So, external force is not required to keep a body in continuous motion. It requires only to overcome the friction. If the surface is frictionless, the ball goes easily and it does not stop if any obstacle is present, any opposition is present. Okay, here and in that case there is no required of continuous application of external force. The ball itself starts moving. Once we apply the force, that means once we push the ball moves continuously. There is no requirement of external force. Therefore, according to Galileo, the continuous external force is not required to keep a body in continuous motion. So, it is required to keep a body in, required to overcome the frictional force. So, this is known as Aristotle's fallacy. So, Aristotle's fallacy means a continuous external force is required to keep a body in continuous motion. Is it clear to you now? Okay. Inertia is the opposition or resistance offered by the body to change its state of rest or uniform motion or direction of motion. What is inertia? It is the resistance or opposition offered by a body to change its state of rest or uniform motion or direction of motion. Uniform motion or direction of motion. Direction of motion. What is inertia? Inertia is the resistance or opposition for the flow of opposition offered by a body itself. Okay, so it is resistance or opposition offered by a body by itself to change its state of rest or uniform motion or direction of motion. So there are three types of inertia. There are inertia of rest, inertia of motion and inertia of direction. There are three types of inertia. There are inertia of rest, inertia of motion and inertia of direction. Let's discuss one by one. First one is, what is inertia of rest? It is the opposition offered by a body to change its state of rest by itself. By itself. This resistance or opposition of offered by a body to change its state of rest by itself. For example, for example, if the bus starts suddenly, suppose you sit inside the bus starts suddenly. What happens? You feel backward jerk. Okay, if the bus starts suddenly, you feel the backward jerk because the lower part, because due to the inertia of rest, because the lower part of our body is in contact with the bus. Okay, when the bus starts suddenly, the lower part also moves with the bus, but upper part remains at rest. But upper part at that time, the upper part remains at rest due to feel of inertia of rest. Therefore, it feels backward jerk. Okay, we observe the backward jerk only when bus starts suddenly. This is due to the inertia of rest. Okay, next, inertia of motion. Inertia of motion. This inertia of motion is opposite to that of inertia of rest. That means it is the resistance or opposition offered by a body to change its state of uniform motion by itself. What is inertia of motion? It is the resistance or opposition offered by a body to change its state of uniform motion by itself. Okay, that means in motion, it would like to be in motion state. That means it does not want to return to the rest state. Okay, that is known as inertia of rest. It would like to keep in continuous motion. Okay, that is known as inertia of motion. For example, if the fast moving bus stops suddenly, what happens if fast moving bus stops suddenly? We feel forward jerk. This is because of inertia of motion. When the bus stops suddenly, what happens? When the bus stops suddenly, the passenger sitting inside the bus falls forward because our lower part of the body is contact with the bus. When the bus stops suddenly means the lower part comes to rest along with the bus, but our upper part remains in motion because of inertia of motion. That's why we feel forward jerk. Okay. So fast moving bus sudden stop आದಾಗ we feel forward jerk. याक forward jerk करते हैं because the body feels inertia of motion. Backward inertia of rest stop ಆಗಿದ್ದ bus sudden start ಆದರೆ we feel inertia of rest, so we feel backward jerk like this. Okay, next inertia of direction. This inertia of direction means it is the resistance or opposition. It is the resistance or opposition to change its direction of motion. For example, other object straight ಹೋಗ್ತಿದೆ ಅದರ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳೋದನ್ನ ಏನು ಮಾಡ್ತಿರುತ್ತೆ? ಅಪೋಸ್ ಮಾಡ್ತಿರುತ್ತೆ. ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳೋದನ್ನ ಏನು ಮಾಡುತ್ತೆ? ಅಪೋಸ್ ಮಾಡುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಸ್ inertia of direction. Inertia of direction is also the resistance or opposition for the offered by a body to change the direction of motion. Okay, it is the resistance or opposition offered by a body to change its direction of motion, by itself. Okay. That means it is the opposition that it opposes to change the direction of motion. For example, if an object moving in a straight line, it would like to keep moving along a straight line. That means it does not take a left turn, it does not want to take a left turn or right turn. That means it would like to remain on the same direction. That is called as inertia of direction. It is a resistance or opposition offered by a body to change its direction of motion by itself. For example, if the bus takes a turn along the curved road, initially the bus is moving along the straight path. If it takes a turn along curved road, then the passenger sitting inside the bus falls opposite direction to the curved road. The passenger falls opposite direction to the curve. So, for example, the bus takes left turn, the passenger falls to right side. If the bus takes right turns, the passenger falls left side. That means the passenger would like to remain along the straight path. That is the inertia of direction. It would like to be at the same direction. That is called as inertia of direction. That object would not like to change its straight path, or it would not like to change the direction by itself. It would change by applying some external force only. Okay, that is known as inertia of direction. Okay, so these are the three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Okay. Next, Galileo's law of motion. We know the Aristotle fallacy. What is that Aristotle fallacy state? Aristotle fallacy states that a continuous external force is required to keep a body in continuous motion. That was incorrect, and it was corrected by Galileo. Okay, and this Galileo's law states that a body moves on a frictionless surface, moves over a frictionless surface, moves on a frictionless surface should move with constant velocity or uniform velocity. Constant means with the same velocity. The body moves on a frictionless surface should move with the same velocity. For example, we can take the example of motion of ball on frictionless surface. Suppose the ball moves over the frictionless surface. Once we push the ball, that means once we apply the ball, the ball starts moving and it does not come to rest until an opposition to the motion of body, to the motion of ball. That means the ball moves continuously if there is no external force, opposite force applied to the ball. That means the ball and also the ball moves with the same velocity or constant velocity. This concludes that the external force is required to overcome the frictional force. This law concludes that the external force is overcome to frictional force, not to keep the body in continuous motion. Okay, you know that according to Aristotle, if I apply the force to an object, the body starts moving. If I remove the force, the body comes to rest. But according to Galileo, once we apply the force to an object which moves on a frictionless surface. Note this, which moves on a frictionless surface. The body moves continuously, okay, with constant velocity, which moves continuously with constant velocity. Okay, that is the Galilean law of motion. So the Galilean law of motion states that a body moves on a frictionless surface. Body moves on the frictionless surface should move with constant velocity. If the body moves on a friction surface, the body comes to rest after traveling some distance. Okay, please note this. The body only moves along a frictionless surface should move with constant velocity. Okay.